Technology in higher education has undergone a remarkable evolution, transforming from a supplemental tool to an integral force shaping how we teach, learn, and innovate. When computers first entered classrooms, they were bulky machines, tucked away in specialized labs, accessible only to the privileged few who dared to explore their capabilities. Today, a smartphone in a student's hand has more processing power than the computers that help land humans on the moon. This transformation is emblematic of the words of Steve Jobs, who once said, "Innovation distinguishes between a leader and a follower." In higher education, institutions that embraced early innovations led the charge toward democratizing knowledge. From the advent of personal computers to the internet boom, these changes have fundamentally redefined what's possible. Students are no longer confined to physical libraries. They now access an infinite world of information with a few keystrokes. Professors no longer rely solely on chalkboards. They use interactive displays and AI-driven tools to bring concepts to life. The rise of technology in education has also opened doors to careers in IT that were unimaginable just decades ago. Fields like cybersecurity, data science, and cloud computing didn't exist when these advances began, yet they are now among the most sought-after professions. A higher education institution that invests in cutting-edge technologies not only prepares its students for these fields, but also provides critical roles for IT professionals within the institution itself. Bill Gates once said, "The advance of technology is based on making it fit in so that you don't really even notice it, so it's part of everyday life." Behind that seamless integration are thousands of IT specialists who design, maintain, and innovate the systems we rely on daily. From the network engineers ensuring fast and secure connections to the software developers building new educational platforms, these careers are pivotal in driving progress. The IT field offers a unique opportunity for individuals to blend technical expertise with a mission-driven purpose, creating solutions that not only enhance education, but also empower entire generations. Whether it's through managing data, safeguarding information, or imagining the next big breakthrough, the possibilities in IT are endless, and the impact is profound. This is the story of Alan, Stephen, and Jason, three IT professionals who, over a combined 60 years, have witnessed and shaped the evolution of the field. Through their journeys as a data analyst, a software engineer, and a network engineer, we'll explore the triumphs, challenges, and pivotal moments that have defined not just their careers, but the IT industry itself.
So I'm Alan Coleman. I am the IT director, well, IT director at ICC. We call it TIS, so Telecommunication Information Services. Um, I'm the director here, have been since 2011. Before that, I was the analyst programmer from 2004 to 2011.
Well, my name is Jason Gunthorpe, and my current role at Etowah Community College is Associate Director of Technology. Throughout my career here at the college, I have been an instructor in the Computer Networking Technology program for around half a decade. And then I moved over to the dark side, we can say, and I have had three different roles here, one of which being the network administrator, and then secondly to that, systems engineer.
Stephen West. Title would be lead developer / systems analyst, and I write code for ICC, and I do a bunch of web development, build a website, but mainly write code all day.
So, as far as in the data world, how I got started, well, I'll just quickly go back to when I got out of school. My first job was as a programmer, and it was on the database administrator team, and so I was directly involved with the data there in the Oracle database, and so I had a few reports that I would have to either create or use in my day-to-day job there. But really, once I came to my current institution at ICC, it was really I was the only one kind of doing any of the data here at ICC. So we were in a time where there was a lot of a big need for automation and to reduce paper. And so I was doing a lot of like basic ASP programming using kind of VB type programming and trying to reduce paper processes, different absence forms and readmit forms and things like that. And so for a few years, that was kind of my focus, was getting rid of those manual processes. As the years have progressed, now a lot of my job is dealing with reports and analytics from requests from administration, mainly using Argos with our banner database. And so it's everything from looking at enrollment trends to day-to-day reports that people need. Enrollment's always been a big thing as far as keeping up with what enrollment should be. We try to do some prediction as far as what enrollment might be in the future. And then the big buzzword from years ago that still is active today is the data-driven decisions. So giving people the data they need to do their job and to make decisions in their job. It's kind of where I'm at now.
Well, I think starting off, we did a lot of desktop development, console development, and object-oriented code. And the industry has switched over to web-based more than anything. And so learning how to build code and programs that run on websites instead of running on desktop has been the biggest change that I've encountered. And it seems like desktop programming is a thing of the past. But and when you're on the web and you're building for the web, you have so many more users than what you have, on desktop applications.
I like to refer to networking as highways or roads because networking is about access, at least in this context. So when I started in the area of networking, or was looking at it in the mid to late 90s, networking was about connecting computers in the same room or the same building. So I can remember token ring and early network topologies and early software like Novell NetWare. So everything was about computers sharing files locally, as opposed to SneakerNet, which is taking a floppy and moving it to from computer A to computer B. We saw the proliferation of internet technologies. We saw what was originally an experiment between the Department of Defense and some universities actually take off and turn into what we call the modern internet. So you have this major expansion over time. The evolution of networking is sort of like the evolution of highways. It's about access, and we have produced a cost-effective way to push broadband, or whatever you want to call it, out to rural communities, bring everyone closer together, and make the world a lot smaller place.
Moving from kind of a manual spreadsheet type system to more of a reporting data analytics system, it really takes, especially in a place like the business office, for example, they would use a lot of spreadsheets, manually entering data, and there's a lot of you're prone for errors, mistyping, things like that, manually creating things. Formulas might be wrong, and really where we've been able to kind of progress that through systems like Argos or whatever the reporting system is you're able to build in all that logic so that it works every time the way it should. The data comes directly from the database. There's no manual entry, so it gets rid of a lot of errors and really streamlines the process. Uh, Allows that process to be handed off to new employees much easier than having to train them on manually entering into spreadsheets and things like that.
So changing from desktop applications over to say web development, web-based, mobile-based, has completely changed what I do because of how it's about to be coded, how it's going to be compiled, how it's delivered to the end user, um, which starts with learning, but basically the code base is totally different. And so learning rather than one language, learning several languages that all work together. Not only that, but the infrastructure as well. So on a desktop application, you are worried about one computer, where in a web-based application, you're worried about a server side, you're worried about a client side, you're worried about browsers that run it, and those types of things. So it's kind of how it's changed what I've had to do.
Let's draw some similarities first. One of the first network management softwares that I can remember is Novell NetWare. So Novell had a server side and had a client side component. So you had a central point of management of resources. So you have access to these folders, these files. It sort of could be represented with drive letters and that sort of thing, which some of that you still see today, even in the more modern clients. But everything could be administered from that sort of Novell NetWare console, if you will. On the Windows side or Microsoft side, um, things were more of a peer-to-peer. You had protocols like NetBEUI and NetBIOS, Windows workgroups. You might remember that term from back in the day. So the idea was we could have a relatively small number of computers on a segment or on a small network, on a hub back then, and they could share files in the absence of a server. And then around the year 1999, end of 99, you had the birth of Windows 2000, which had this really neat thing called Active Directory, which we still use today, even in our hybrid Azure deployments. So Active Directory was a powerhouse from a management standpoint. It had the things that the Novell NetWare management solution had, like the management of users and groups, the management of folders and files and that sort of thing. But it also lets you actually configure your clients, your endpoints, like with group policy, and it could do other fancy things, and it ran TCP/IP without the overhead of some of the other protocols that Novell required, at least back in the beginning. Today, the college is looking at the modern incarnation of System Center Configuration Manager, which is an imaging and software management tool for large-scale networks, very large-scale networks, into the tens of thousands of clients. Well, that software is dependent on Active Directory, which is dependent on sort of a Microsoft server client environment. But with a tool like that, you could effectively manage users, groups, access to files, folders, and even configuration down to the machine, even to what operating system version the machine is running. There's other products too that institutions use. Citrix is a product that we use. Without Active Directory, it would be very difficult for us to even implement a VDI solution as common as Citrix. Networks have grown exponentially since around 2000 or the late 90s. And because of that, systems administrators And companies and institutions like ours at Atawamba, we've had to think about tools that we need to have in our arsenal to manage those larger scale operations.
Uh, so as far as the change in getting data collected is, uh, I mean, it's night and day. So the difference is in the past, you would have paper forms, everything from admission applications through financial aid, everything on day to day. Like I said earlier, the excessive absence forms, readmissions forms, uh, grades, everything. Everything was manually entered. So there was, a lot of errors and mistyping and things like that. Today, everything, all data is captured electronically. So admissions applications, all scholarships applications, any data we take in from a student is going to be electronically captured. Of course, those things are processed through an office, so there's data checks that happens. Everything that instructor submits as far as grades and attendance is all done electronically. All those forms and things. So the data is free flowing through the database. It's coming in and being reported out much quicker, much more efficiently, and hopefully more accurately.
I guess being an agile programmer and the approach to it, one thing that I found, at least in the entire tech industry, and in my opinion, is if you learn how to do one thing and do it really well, if that's what you stay at doing, then you're going to be deprecated really quick and be antiquated out of the industry. So you have to stay kind of agile as far as coding and programming because there's always something new and there's always some better way of doing something. And that's a lot of my job is learning more stuff, researching how something is done. I go to different conferences and trainings and find out how developers are doing it their way. And I've found so many different ideas that way too of like, wow, that's a much better way. I'm going to start programming that way, or I like the way that language works. And there's so many frameworks out there now that are built on top of JavaScript, and learning those and figuring out how they're more efficient and how their performance is better. And you have to kind of be able to switch around and be agile to stay at the cutting edge, I guess, create a good product, or you're gonna antiquate quickly in the industry.
One thing that I will hand it to Steve Jobs and really Apple in general is they really nailed this mobile device formula. So we have a term called BYOD, bring your own device. We have an entire market and industry that sort of revolves around the management of what that is, what that ever-changing thing is. So Mobile Iron is one of them. Microsoft Intune. The term we use is mobile device management platforms. So from a network administrator standpoint, it becomes difficult because now we're talking about devices that are beyond the scope of management. When we get back into the mobile device management piece, Microsoft Intune is the one that I'm most familiar with. The idea is to leverage what the end user wants to use. In other words, create value out of what the customer or the end user values. We have a new technology or set of technologies that are introduced. They are disruptive. IT is not ready for those things. We're not expecting those things. We want everything to be the way that it's always been, and now all of a sudden it's not. So then we have some innovators create a market, and they develop mobile device management strategies and products for the network admins or the folks that consume those type products to implement them and extend the umbrella where all of a sudden we're not getting so wet because all of these devices are outside that umbrella. So it's just the evolution of management products.
As far as the idea or the concept of big data, I think the biggest impact for us there is the way we work with MCCB as far as all the 15 community colleges collecting data and then sending it up to MCCB. Um, the in the state of Mississippi, the legislature goes directly to MCCB, our board, to request data, and then they use the data they've already got from us to create that, to create actionable data for the legislature. So it's not really us reporting that directly, where it's being filtered through the board, and um, so at this point, it's been 10 or 15 years ago, there was a big push to make sure everybody's data was the same, everybody was using the same rules, and same, to get the data consistent between the community colleges, so that whenever that data was put together and then given over to the legislature, that it actually made sense, and it was good data. So I think working with colleagues at other schools or our equals at other schools, there was a lot of work that was done there several years ago. Not so much lately because we think we've got a good process. But I think that's kind of more the idea of big data, where everything, it's not just what you're doing day to day. It's being kind of pushed up to a larger data set to make bigger decisions on a larger scale.
I think in some small cases it's pretty efficient and handy, but what I worry about is if AI is creating code for you, and we're really dependent on AI creating code for us, and who's keeping AI in check as far as what kind of code's being created and the output that code's going to create. And so those are the types of things that ring alarms or bells to me in my perspective of it. I think, again, like for something simple, it's probably pretty handy. I think for figuring stuff out, it's probably pretty handy, right? So instead of researching the web on how to make code do this one thing, you could just ask AI and it'll spit it out for you. Then you can go, oh, okay, I see how that works, and you can start integrating it in your own code. But if we're just trusting whatever AI spits out over time, we're not going to know any different. And I don't know, there's something about that kind of bothers me.
As far as managing the data set, honestly, the size probably doesn't make as much a difference as the understanding of the data. So when we're looking at data, really the example that I always give is somebody asks you, what the enrollment is. And that can mean a lot of different things to a lot of different people. It depends on what day it is, what time of the day it is, what that enrollment is. So I think the biggest hurdle for me is making sure people understand what they're asking. The way I kind of get around that is anytime somebody asks for data, I ask what they're using it for and what the purpose is, and that helps me figure out exactly what they're asking. Besides, just some generic, question as far as data, I can kind of drill down into what they're using it for and get an idea of what they actually mean by that request. So I think it's more just the understanding of what the data is and what it's been used for.
The challenges when it comes to network engineering in cloud computing is you have to think about resiliency and bandwidth. If one of the most common applications that we have in the cloud right now is email, I don't know of a lot of folks that are doing email on premise anymore. We use Outlook, we use Exchange Online, which is effectively Office 365, or we use Google Gmail, we use one of those. So we can effectively say that modern email is cloud computing. It really is. So what goes into play, or what should be considered when we're engineering a network for that type of application? Well, with resiliency, what I mean is that you're always connected. You also have to think about bandwidth. Sounds really great to put everything in the cloud, but what happens if you don't have a big enough connection to the cloud to deal with that? So it's not like we can just make a decision and that's always the way it's going to be, because that could change with the introduction of one piece of software. That entire thing could actually change. Network engineering is about building highways for access. And when you're building highways, you have to think about the landscape, what type of vehicles are going to be on the highways, how often they're going to be on the highways, how fast they're driving, how fast they need to drive. Can the highway be shut down? And if it does, what does a detour look like? Is there another highway nearby that we can use to do traffic on if we're doing maintenance? So it's quite interesting. It's a bit more than just plugging stuff in.
So with visual tools, it graphs and charts and things like that, it is easier to communicate that. Um, Unfortunately, I think it also comes back to what people are asking for is like, we can do all these pretty graphs and charts, but nobody really knows to ask for that. Let's say, I go back to the enrollment as an example. We've got plenty of enrollment reports and things like that, and nobody's saying, well, give me a graph of enrollment over whatever. So we've got some reports that we put together, and we were able to put graphs and charts on it. And it is definitely easier to communicate that. It's just the end user, they're not picturing that in their head before they ask. You kind of have to, I guess, as a data analyst, you've got to figure out exactly what you've got to show them and kind of predict what that visualization needs to be before they ask for it, I guess.
Well, to be honest with you, frameworks are awesome, and I couldn't do my job without them because I'm basically the only programmer at ICC, and we're a pretty decent sized institution, and we have a ton of web developed programs and modules that are used by thousands of people every single day. And for one guy to develop that is a lot. But by utilizing frameworks, I've been able to be efficient enough to create that much product on my own and maintain it and build it well. So, instead of building a web platform from scratch, which would take forever, there's a web framework that I can put in place and I can build on top of that. So all this other work's already done. Our mobile app's kind of the same way. Rather than having to build a mobile app from scratch and learn different languages for different platforms, I'm able to use a framework and then just build on top of that framework that works across all devices. And now I can create a mobile app, maintain it efficiently and quickly all by myself. And we have a junior programmer now, and he's able to come in and learn that framework too. JavaScript's not much different. It has several frameworks as well, and utilizing those makes you a little bit more efficient too. So I use frameworks a lot, and it's invaluable in what I do.
One of the first challenges with IoT is you have to identify what IoT is. So what is IoT? What are Internet of things of the internet? And I think if I ask most people in this department, they'll think about things like, well, light bulbs or heaters or toaster ovens, vacuum cleaners, and that sort of thing. But in the case of network administrator, you have to see that those devices are not equivalent to your computers that your faculty and your staff use, or your students or your labs used. In other words, they needed to be treated differently. The other thing that makes IoT difficult, I believe, is that it's maybe slightly unregulated. For example, there is no rules in place to prevent a student at Etowamba to buy any IoT device that they want to, as long as it doesn't set the room on fire, and hook it up in their room and turn it on and let it get an IP address. So light bulbs, toaster ovens, lamps, all of that sort of thing. So there is this real reality where you don't really know what those devices are. And knowing what those devices are, there are management softwares that can show you sort of what your network inventory is. They use a fingerprinting type technology, sort of a layer 7 signature. So if the light bulb calls out to Samsung or whoever the manufacturer is, then we can take a look at what that application stream looks like, and we can say, okay, well, based on what we already know, we know this is a Samsung light bulb, and we can flag it as a Samsung light bulb and not think that it's some sort of, weird something that's going on.
I mean, I guess as far as staying relevant, just continuing to do training on the tools we have, being open to new tools. Argos, it's been around for a long time, but as far as ICC goes, we didn't really get heavily utilizing it until, it's been less than 10 years ago. So before that, we used software called Toad, and we were doing Toad reports. Basically, that's just SQL, it runs SQL statements, and people were getting just CSV files out of it. They were manually running those scripts. So the move over to Argos has been great, but it's ever evolving also. I haven't looked into it yet, but just a month or so ago, they announced that they now have an AI plug-in that's supposed to do some stuff. So it's time to start diving into that now.
The languages that I use the most often would be Visual Basic, which a lot of people out there kind of frown on. JavaScript is another huge one. Of course, HTML, markup language, cascading style sheets, and a lot of SQL to do database work. I would say probably the most difficult might be a toss-up between SQL and some of the JavaScript frameworks that I use. And JavaScript in itself isn't too bad, and I use a lot of jQuery framework for JavaScript. When you get into some Angular frameworks and things like that I've had to use for a mobile app, those can be pretty difficult and have a pretty large learning curve. But those are the frameworks that are out there today, and that's what everybody's learning. So you got to know how to do it to stay competitive.
I think so. The evolution of data analytics is going to be at least, with technology, it's hard to predict a decade out, I would say, but in the next few years, AI is probably going to be the biggest game changer. Data analyst is as a job is still going to be very important because AI is not perfect, so you've got to be able to tell what makes sense and what doesn't, and where to use the technology. But I think AI is going to probably impact everything, and so data analytics for sure is going to be able to look at data. It's going to be able to predict data. It's going to be able to tell you what data you should be using to make decisions with. I think it would end up being big as far as people, as long as people pay attention to where it's used.
Outdoor wireless environment that we had to work through and are continuing to work through here at Etowamba. So in wireless technology, we are, of course, providing the end device connectivity through some sort of wireless modulation, a host of wireless technologies that we could call 802.11 something. And we ultimately have a device that is connected to a radio. And the nature of mobile devices or mobility is that the device is going to not be stationary, so it's going to move. So we're going to be close to the radio, far away from the radio, and eventually we're going to migrate away from the radio enough to where we can no longer attach to the radio. So on a very basic level, so what we do is we add a radio that's within a certain threshold of the original radio. And there's certain formulas that you can use or recommendations you can use on what that overlap threshold should be. And there's some variables in there. But ultimately, the device is going to either break connection from the first radio and then latch on to the second radio, or if your threshold is correct, the device is going to do what's called a roam. It's going to roam from radio 1 or radio A to radio B, and that is a transitionary thing. We want that to occur without the end user or the end application, more accurately, to even know that that happened. So there's two types of roaming. There's a layer 2 roam and there's a layer 3 roam. Whenever you do layer 2 roams, you're not changing an IP address, you're just renegotiating a session essentially. So it's very easy to make that a transient experience. For example, you could be on a Wi-Fi phone call and you could be walking down a hallway, jumping across possibly 2 to 3 APs, and your phone call is not going to be interrupted. You're not going to hear any kind of clicks or sparks or robot sounds like we hear on the voice over IP phones occasionally. It's just going to be a transition. Well, layer 2 transitions are easier to do because we're using the same VLANs, the same sort of structure across the different APs or the different radios that we have. Layer 3 roaming is a bit more complicated because now we're roaming between two APs that are on different VLANs with different subnets, different IP address structures, different gateways, possibly even different DNS or other settings. But we want that to be transient too. So how do we accommodate that? And there are layer 3 roaming solutions out there. We looked at the one applicable to Ruckus, which is the wireless hardware manufacturer provider that we use. But trying to do that outside is extremely hard to do. So in the initial network design, we had buildings set up on different layer 3 structures, different layer 3 subnets. And then the outdoor APs themselves, in many cases, almost all cases, were on the sides of buildings or on poles that were connected to buildings. So there is this outdoor roaming problem now that we've inherited because the APs that we're trying to transition users to and fro are on different layer 3 subnets. How are we going to maintain their session and their IP addresses? Is the expectation they're just going to lose their internet and get it back when they walk close? So there's all sorts of problems in that scenario to solve. So we had to go back to the whiteboard and we had to say, well, this network design is not inherently bad. There are good things about it. One of the good things was the reduction of span and tree, the areas that span and tree propagates. but it causes a problem in the outdoor roaming capabilities that we want. So we had to apply some weighted factors. We say, well, the value of the wireless system roaming properly has a higher weight than everything being a layer 3 entity and span and tree being a little easier to manage. So we had to go back to the drawing board, and I had to really think through a layer 2 design where VLANs could live everywhere they needed to, but still mitigate some of the problems that you have when you stretch layer 2 boundaries to the degree that we're doing it now, such as network loop mitigation, broadcast storm reduction, all of those kind of things. So you trade one problem for another problem. You just have to decide which problem that you want and which problem is best for you to live with. And in this case, the student experience wins. So we try to accommodate whatever problems are introduced with a model that's most conducive to a better student experience.
So, I mean, as far as how my career has shaped my life, just to be honest, I try to not let it as much as possible. I do have some nonprofits that I do websites for, so it's allowed me to kind of use my talent or whatever you want to call it outside of work and kind of help others in a volunteer type way. Um, but you know, the big buzzwords, the work-life balance. I try to keep work out of it and try to outside of work, try to keep it to my kids and wife and um, things like that.
There's always going to be new feature adds to everything that you build, and there's always going to be maintenance to everything that you build. And you just gotta, like, when you're beginning to design whatever it is you're building and architect it, so to speak, you need to make allowances for the fact that you're going to have to maintain it for a long period of time, and you're going to have to be able to add features and things in the future because there's always going to be something like that. Now, if you build a product in a way that it's really difficult to add a feature later on, you're going to be in trouble. So I usually design, when I approach a product, I design it in a way and architect it in a way that it's scalable, I guess you might call it, where I know I can go in and easily add features because everything logically lays out the way that it's supposed to. And so I don't know what features may come in the future, but I do know that my code is logically laid out in a way that whatever comes, there's a place for it to fit in. And therefore, again, being a solo programmer, and having 80 to 100 different products under my belt with different features that need to be added all the time, I can, because it was designed properly and written properly, I can usually, have a turnaround on feature adds that is pretty efficient, pretty quick. And then the maintenance of it, it does start to add up too. I mean, maintenance I would consider to be like bug fixes, um, just cleaning up code and making it more efficient. Um, that's a little bit different. It's hard to anticipate what bugs you're going to find, but having a good troubleshooting model, allowing your code to log itself where you can, even though you don't know what problems come up or are going to come up, you have an efficient path as far as logging and whatever you can do to record exactly what's going on so that you can kind of go in there and quickly figure out and trace down where the problem's at. So you want to be efficient, you want to be quick at what you're doing, and how you design in the front end impacts that tremendously on the back end. So you're going to have more and more frameworks that come out that are going to be more efficient. And what I've found too is the industry's kind of like before. If you want to build a website, you had to know a lot about building a website and take a lot of time and build it from scratch. Now you can get a free Wix account, have a website up in just a few minutes. You don't really have to know code. You just get on there, drag and drop, and boom, you've made a website. Mobile apps are getting that way as well. There's a lot of things out there now that you don't really have to know a lot of code, but you're coding, right? I see the industry going that way for sure, but I don't think it can rely on that. And then AI, I think, is another piece that I can't put my finger on, but I know it's going to impact it tremendously as well. So, is there going to be a point in time where if AI can spit out code to do stuff, well, what's the point? Just have AI do the stuff, right? So, um, I see it being. I think I think as time progresses, the people that are involved in what I'm doing probably know less and less about the little details of how things work and have more of a generalized view, such as building a Wix website, for instance. I think we see it, probably going to see it going down that road more and more.
Network engineering is about virtualization, is about making one device or one virtual appliance or virtual server have the capability of living in multiple geographical areas without IP address changes. Everything always routable and resilient, etc. The ability to use what we would call higher end commercial subscriptions like MPLS, switched Ethernet, in conjunction with cost effective broadband type connectivity, like from your cable TV providers and that sort of thing. For example, if we were to try to put together or network engineer a resilient network solution for a customer, well, maybe the customer could afford some sort of higher end fiber circuit back to headquarters or to the internet, but maybe they couldn't afford two of those from two different providers. So we would maybe procure some local broadband, like smaller circuit, maybe a 25 megabit or 100 megabit or something like that from like a local cable TV or telecommunications provider. And then we would use something called um, software defined networking. So SDN, an SDN device would allow both of those circuit types, if you will, to terminate, and then we could use this device to route traffic across either one of them in any fashion that we wanted to, but it'd be a cost-effective solution for the customer. But into the future, I'm interested to see where this AI and robotics marriage is going to go. I have tried not to be too the right term, too sort of caught up in it. But even some of the conversations you hear Elon Musk having, I think that in the next 2 decades, we're going to be expanding this thing even further, and we're going to have this huge proliferation of robots, both commercial and domestic. They're going to be all connected. They're going to be doing jobs that we have sort of people doing now, and we're going to have to engineer networks and systems to make all of that work and put all of that together. But I think there's also going to be some moral decisions that we're going to have to make, and there's going to have to be some security concerns that we're going to have to come to terms with, and you're going to see a market sort of arise out of that to sort of manage that. Even you may have different software and hardware providers that are trying to manage that the best way that they can too. So that's what I can't quite see the end of the tunnel with, but that's going to be a an untapped market for someone who's getting into networking in the future. Building automation too, network automation, building automations.
I'm kind of maybe an oddball in the tech world because most tech guys that make a living of it are known as nerds or whatever. I don't know if that's what I am, but usually if I'm not working or at work, I'm seldom touching the computer at all. So my day to day when I get off of work from writing code for 8 hours, I'm liable to go straight home, jump into a pair of blue jeans and a t-shirt, and go out in my wood shop, work on something, be outside and have a fire and cook out, or I just like to get out and get my hands dirty and working on something. I love to hunt and fish, and so when hunting season rolls around, I'm in the woods, I'm hunting. When there's no hunting season, I'm out on the water as much as I can fishing. Very seldom am I dealing with code or doing anything that even resembles technology or tech work. So
Yeah, it's hard to predict 20 years down the road, but I mean, I guess what I try to do is look back to what it was 20 years ago. And you look at how it's changed and how everything is automated, everything's online. But really, I think, like I kind of talked about before, AI is probably going to be the biggest uh, disruptor, I guess, at least in the next few years. So probably long term, depending on what AI ends up doing to technology and IT, um, that could be the biggest change. I don't know what that's going to end up looking like though, as far as what our jobs are going to be.
I got a couple answers for what I'm most proud of. What we use at ICC that I might be most proud of is probably any system that runs every day with lots of use and doesn't break. And so I'm trying to think through some of that. One of my biggest systems I ever built was for health science application management. So we have a lot of people applying for health science programs at ICC, and I built an entire system to all the way from the user applying to how they manage those applications. But the way they pick and choose who's going to get a seat is, different grades on your transcript are weighted differently, and certain things that you're able to do outside of school can be weighted, and you get certain points for different things, and so it gets to be really complicated. And we was able to build that so that it's very accurate. Everything's weighted correctly. And then the system runs itself. So once they start it, they push out offers. As people reject them, alternates roll in automatically, and it's a really big system with a lot on the line if it doesn't work, and it works, and it's worked for years, and it's just probably the most code of any system I've built. So I'd say I'm really proud of it. But one thing that I built that's always stuck out to me that I've really enjoyed and was really proud of is a coworker of mine, Jason Gunthorpe, was in an electronics class, and he was having to build like little circuit boards. He had a project he wanted to do, and one of them was to make a lawnmower drive with circuit boards. He put some servo motors on it, and he was able to get the electronics to work, but he needed software to tell it to do anything. So he paired up with me, and I got to get a laptop out and write code that would send signals to the circuit board, make certain motors run. And when I got done with it, you were able to take a joystick and drive this lawnmower around the classroom, which was pretty cool. And then I came up with a way to record all of that, so it would record a route, and then you could just hit play and be hands off, and it would just drive itself around the classroom. And that's always been kind of one of my funner projects that I was proud of. So.
Much of my job is in the area of teaching. About half a decade of it is professionally as an instructor. So, though I've served so many different roles in IT over the years, my enjoyment, main enjoyment from all of this is learning new things and teaching things and helping teach things to people and watching them grow and watching them do well and watching them have their own rewards and that sort of thing. And to me, that's been something that's kept this thing alive as far as a career in IT. And I think that that has impacted me outside of my professional career because, well, in a way that I work with my children to teach them or to talk about something new, or with my spouse or with friends. This area is always changing, so there's always conversation. There's always so many things to talk about. It has been a lucrative career financially, so I can imagine having a career path that maybe wasn't as rewarding financially. That would have been even more difficult. So that's been such a real value too. It also can be challenge to break away from sometimes. Your your mental health, it's the right term. Your number of folks that have had mental health concerns that work in IT is actually pretty high. It's this career path can be taxing on a person because it can demand a lot of time, and it's ebb and flow. Sometimes you feel like you're working 24/7, and then sometimes you get a break. But it can be a little over demanding, I think, sometimes. And then what you have to do is when you have a career like that, you have to learn to break it every once in a while, and you have to like I've been an Orthodox reader at church, so that allows me to focus on reading the Psalms and what David had to say about some things, and then reading the services. It When you have a career path that can eat you if you're not careful, then it will actively make you look at finding some other outlets and things to do. Some people like to play games. I like to play guitar. I like to ride my new to me motorcycle and just do some outdoor things with the kids. So I think it's taught me a little bit about balance, at least in the later years. Maybe in the earlier years, I struggled a little more with not having that balance the way that I needed to. But in the later years, you learn to appreciate it, makes you appreciate those things a little more.
So, advice to somebody starting out with that in IT, I would say there's a lot of angles you can come at it from. There's a lot of different jobs, a lot of different responsibilities with IT. So, um, make sure that you like the angle you're taking, and dig into it. So, um, you know, you can say you want to be IT, and from the outside of the IT world, everybody just thinks we're all just computer guys, right? But once you get into it and you figure out what your responsibilities are going to be, within your sector of what you're doing. It's a wide field, so there's a lot of different things you can do. So you've got to figure out what that is within that field and kind of dig into that area, and do be the best you can be at that, and there'll be opportunities for you.
Honestly, I love what I do. So even if it's my least favorite, doesn't mean that there wasn't some enjoyment. But to be honest with you, what a lot of people do when they get into this field and in this industry, I can't tell you how many people I know that get into programming because they want to make games and stuff like that. And I have to tell them, I'm like, in reality, if you're going to be a real programmer and have a job, then you're probably going to be writing some mundane stuff, right? And so I write a lot of mundane stuff, and I write a lot of forms, a lot of tables, a lot of web pages that display tables of data, a lot of forms that people fill out and save the data and manage the data. And sometimes they can feel like it doesn't matter what I'm building, it's basically a cookie cutter. It's a completely different system, but at the end of the day, it's just displaying data, creating data, deleting data, and editing data, right? And that can get pretty mundane, and so it's probably my least favorite. And after doing that for 6 or 7 months, usually if I have something interesting come down the pipe, I'm really excited about it, and because it's challenging and it's just something different.
So I used to live this question. The incoming freshmen, they come into your first class, and some of them have no clue what they're doing, what they intend to do. Some of them think they've got it all figured out, and they don't even need your class at all. So you just have such a variety. But what could I tell someone? So I think to start with, never downplay the significance of networking. What I have seen time and time again is by building good quality relationships with other people that have the same interests as you, the same values as you, and the same career path as you, I see these people helping one another. I see them helping one another with what certifications to do, what additional classes to take. I see them helping each other get jobs at the same place or transferring to other places or getting promotions and all of these sort of things. So there's such a value in that. In fact, I think the value is up there with academic achievement, because I've also seen people that were extremely smart and extremely capable, but they just couldn't quite build quality relationships that would have allowed them to go a lot further in their career path. They just couldn't quite shed the negative personality traits or quite overcome some of their other limitations. So first thing is, regardless of what you know or what you do, always value your brother or your sister. Always value the other person and try to build good relationships. The second thing that I would say is always go into a class or a conversation or a workshop or a conference and assume that regardless of where you are, that you can always learn something and take something back. That's always true. Assume zero knowledge, infinite intelligence. And because I have been in conversations and even at a conference or two, and that particular topic is something that I had taught myself. I had drawn it on the board. I would consider myself proficient in that particular topic, to say the least. And just through having a conversation with two other people and getting their perspective, I learned something new. I learned another way to teach that concept, or I learned another possibility, another way to do that particular thing. So it doesn't matter where you are. If you don't know anything, listen. And if you know everything, listen. Because there's always something to take. And then lastly, I would say approach the goal with the end in mind. I think that's maybe a Dave Ramsey thing. Maybe that's a Stephen Covey thing. That sounds more like a Stephen Covey idea. Approach with the end in mind. In fact, I've got I don't know if it's on your camera here, but I have a determination plaque. This is what my instructors gave me upon completion of some classes, maybe even for graduation. And there is rarely a substitute for grit, rarely a substitute for perseverance, for achievement under pressure if you will just grit your teeth or hold your breath and do what you need to do to have completion, A, but B, also have completion in a proficient manner. So I'm talking about a good quality grade, certification, those type things. If you will just do those things, then the reward will be exponential. Like, if what I mean by that is, if you invest a year in a certification, the reward for that is going to be multiple years. Or if you invest another 2 years in a degree, the reward for that is going to be lifelong. So it's all about, to some degree, it's about delaying what you want for the present for a better future. And I think that's the key. Us outside of the hey, attendance, come to class, those type things. Maybe an ounce of humility along the way too.